Alright, so we're going to be refactoring our code, so the idea is that to take the class declaration, every class declaration with member function defined in line, and move the executable code, basically the definition of functions, out of header file and place it in the implementation file .cpp. So let's open both of these files. Right now what we have is two of these files look like this. So essentially the idea is to find basically the definitions of functions, constructors, of everything that we have here, and relocate it into the implementation. So let's see, what can we do here? So this is our base class. We can just leave it the way it is because this is just very trivial and only contains initialization of all of its members by using a constructor initializer list. So virtual draw is already implemented in other classes because this is pure virtual function, so it does not have any definition. This is another virtual function, another pure virtual function without definition, and the virtual constructor we can also leave alone because it's just so trivial. So I'm not going to make too many changes to the primitive base. But as soon as we begin to see classes with function definitions, we can try to relocate these functions. So for instance, right here, these two functions can be moved out to the implementation file. So the process is simply to copy and paste. Okay, so that's sort of like step number one. I typically select everything and press Shift Tab to adjust the indentation the way I like, and then use the name of the class right here. This is primitive line, and just basically use it, prefix every function name with the scope of the class to which this function belongs. So this is the process, so it's quite simple. And once we're done with this type of work, it should be quite trivial to just take what we have, remove it, delete, and replace it with semicolon. Right here, the same process. I mean, you can just add semicolon and remove inline function definition. So supposedly, if we complete the work like this, it should be much easier to interpret the design of the class with its constructor. Here I just, because this constructor is so primitive, it just only uses the initializer list to initialize the base class with all of the corresponding parameters. So it's trivial right here. I'm not going to move it out. But here it's just easier to observe that this class has the draw function and function to update x2 and y2 coordinate for mouse handling. So here's primitive circle. It also has draw and update, and also has the same type of constructor. So I'm just going to once again take a copy and paste it into the implementation file like this. Again, I just typically select everything, press Shift Tab to adjust indentation, use primitive circle name in front of these function names. That's the scope of the class. Alright, so these are now implementations of these functions, and here we just use semicolon and remove definitions. So replace definitions with semicolon like this and get rid of the actual definitions. Right, so this again is just makes it much easier to interpret the content of the header file, and quicker observe the things that are part of the class design. A primitive rectangle right here, same idea. So it has, again, these implementations. So they just routinely go to the implementation file. Just be careful to use the correct name of the class, because when things, when we copy and paste things, it's just easy to make mistakes. So sometimes you probably want to preserve a copy of your work before attempting all of these modifications, just to be sure. So now once again, I replace the implementation with just function declarations. Just keep whatever style you like, but this makes it so much more readable. All right, so this is a declaration of function. This is misspelled, declaration. All right, so these are function declarations and create primitive. So this is one of the declarations. We already have its implementation inside the implementation file since laboratory 15. And this is our CDrawBox. So this is another class that we have to work on. So again, I'll just leave alone the constructor. However, let's just demonstrate maybe this constructor also moved to implementation file. Let's do this. Okay, so just scrolling down here, and I'm going to take all of these function definitions, carefully select them like this, with all of the details, all sorts of things that go and taking place inside here. There's quite a bit of stuff happening, right? So we can just do this, and this is now the ending of the class declaration, CDrawBox. I'm just going to copy all of this and paste this inside my implementation file. Now, instead of just adjusting everything at once, I will do this step by step, one function at a time. So I know that I need to make the class scope prefix in front of every function name, and that's pretty much all that's required to complete the work in the implementation file. Right, so this was CDrawBox all along. So I'm just going to carefully, every name needs this type of prefix, and once I do that, I'll just move it to the left. Okay, so these are adjustments that we need here, and that just becomes very tedious, but we just do this step by step. So this is the longer function handle, so we just be careful to select everything. So that's the closing brace, and I just press Shift Tab to adjust the indentation here. So this is all we need in the implementation file. Just make sure that everything is prefixed nicely right here. Just that every function and constructor, if it includes constructors, gets this prefix. So now we can save this, and going back to the header file, just in this section, again, we'll be just replacing, just semicolon replaces everything that the actual definition now moved to the implementation file. So once again, just make sure that you keep the semicolon, and we can keep doing this. And so this is the last function to take care of, I think. So this is a new new look of DrawBox class declaration. And so I hope you agree with me that this is much easier to work with, because really we don't need to see all the time all these details about function implementation. All we need to know that we can draw the border. If we really have to dig into some details, we can always open the implementation file and find out what's happening here. But most of the time, we just rely on the protocol, like, what are function parameters, what are function names, when do we need to call these functions. So all this information is already present in the header file in class declaration. So this is a much nicer arrangement of declaration and definition. So let's just make sure that we test everything. So we just need to make sure that we build. And I keep getting some of the linker warnings here, which I'm going to ignore. But the important thing is that the entire project built. And I'm going to press Control F5 to just test. So this is our selection of different types of drawing primitives, but now we also have the possibility of drawing these primitive shapes, switching from one type to another type. And the only thing that's still not fully implemented is the filled version, which we will take care on in our next exercises. But overall, you see that the functionality continues to work exactly as we had this at the end of the previous laboratory exercise. But now we're prepared for adding new features and new ideas to the Scratchpad application.